Hello students, in the previous class I have spoken to you about azimuthal quantum number. Okay, azimuthal quantum number, and I have always told you that azimuthal quantum number represents the suborbit number. I have told you that orbit is further subdivided into suborbit, that is represented for azimuthal quantum number. Azimuthal quantum number होता क्या है? It is in suborbit number, nothing else more than that. Okay, so if I see to the azimuthal quantum number, if I see this is what the nucleus, this is the orbit. The orbit is further subdivided into small fragmentation of suborbits over here. Okay. The nucleus, this is the orbit. The orbit is further fragmented into suborbits. Okay, it is further subdivided into fragmentation of suborbits over here. These are all suborbits. Okay, and this is called orbit number 1, and this orbit number 2. So this orbit number 1, orbit number 2, and dot lines are basically represented as in the form of what? Suborbits over here. So when we speak about this one, suborbit represents azimuthal quantum number. Suborbits represents azimuthal quantum number. Okay. So when we speak about this suborbits, just see this one. Azimuthal quantum number is represented by L. L से representation होता है. Today only azimuthal quantum number. Slowly we'll go for it. Nothing to rush. We got 2 years. Okay. L. Where L is always equal to n minus 1. Where n is the number of orbit. Number of orbit. Okay. L is the number of orbit. L is the azimuthal quantum number. N is the number of orbit. If n is equal to 1, L will be equal to 0. Okay. If n is equal to 2, then L will be equal to 0 and 1. Why? Because the electron will first go to the first orbit, then it will proceed to the second orbit. If it goes to the first orbit, L will be equal to 1 minus 1, that is 0. Then it goes to second orbit, that is 2 minus 1, that is equal to 1. That is why it's called 0 and 1. Okay. So if n is equal to 1, then L will be equal to 0. If n is equal to 2, then L will be equal to 0 and 1. If n is equal to 3 is there, that means L will be equal to 0, 1 and 2 or not. Okay. 0, 1 and 2. If n is equal to 4 is there, that means L will be equal to 0, 1, 2, 3. Are you getting me? That means if n is equal to 3 is there, the electron will first go to the first orbit. If it goes to the first orbit, that means what? L will be equal to 1 minus 1, that is 0. If it goes to second orbit, then it goes to second orbit, that is 2 minus 1, that is equal to 1. Then it goes to third orbit, then 3 minus 1, that is equal to 2. Okay? N is equal to 1. N is equal to 1, L is equal to 0. N is equal to 2, then L is equal to 0 and 1. N is equal to 3, then is equal to 0, 1 and 2. Getting it? Then if it is N is equal to 4, that means the electron will go to the first orbit. If it is first orbit, that means L will be equal to 0. Second orbit, that is 2 minus 1, that is 1. Third orbit, then it will go to the 3 minus 1, that is 2. Then fourth orbit, it is what? 3 minus 1. Okay, 4 minus 1, that is equal to 3 or not. Okay, this is how we represent this one. ठीक है ना? First मतलब lower energy. Let's say when you are passed off your 10th, मतलब you are going to go for 11th standard. Right now you started for 11th standard. You have to pass your 10th standard, then you proceed to the 11th standard. That means lower से higher जाना. That is, the electron will migrate from first orbit to second orbit, third orbit to fourth orbit, like that way. Okay. And while migration, L will be always minus 1, minus 1, minus 1. Okay, n minus 1. So here it is. Number of orbit will be always equal to number of suborbit. Just see, agar number of orbit is 1, that means L will be equal to 0. Okay, that L0 is countable to be as 1. है ना? Numbers to it. If n is equal to 2, then L will be equal to 0 and 1. That is 2. Correct? If n is equal to 3 is there, L will be equal to 0, 1, 2. That is equal to 3. You can understand the number of orbits is equal to the number of what? Suborbits. You cannot go away from that particular part at all. Okay. Now, as we have taken into consideration, that orbit number was represented as, orbit number was alphabetically represented by KLMNOP. Okay, suborbit number is represented as what? SPDF. Okay, just KLMNOP मतलब 1, 2, 3, 4, 5, 6. SPDF को लिखेंगे 0, 1, 2, 3 G. Understood? 0 को S लिखेंगे, 0 को जो लिखेंगे तो S लिखेंगे, that's called a sharp. Okay, 1 को लिखेंगे तो P, that's called a principal. 2 को लिखेंगे तो D, that is called a diffused. 3 को लिखेंगे तो F, that is called a fundamental. 4 को लिखेंगे तो G, that is called a generalized. That's why the name signifies for SPDF G in alphabetical notifications. Whereas in the case of orbit number, it is represented as KLMNOP. Okay. Now, the shape of azimuthal quantum number, the shape of azimuthal, shape of suborbits, shape of suborbits. How it is represented as shape of suborbits? S is represented as spherical. That is, the electron will move in a spherical notch. Okay. Similarly, P will be represented in the form of a dumbbell. That the electron will move in a dumbbell notification. Matlab electron will move like this way. If the electron is placed like this way, if it is moving like this way, you will understand that it is in the case of what? Dumbbell mode. That is P orbitals. Okay, P subshell. Sorry. Then D is a double dumbbell. Double dumbbell. Then F, that becomes complicated. Okay, complicated. Then G, that is called a hyper complicated. So, if you see the electron being placed, how will you identify that the electrons are placed in S, P, D and F? By notification that is being shown over there, where it is being seen over there. Just see. You have a S orbitals, S subshell is there, that the electron will be spinning in the form of what? Spherical shape. P subshell is there, it will be spinning in the form of dumbbell shape. D subshell is there, it will be spinning in the form of double dumbbell shape. Then F will be complicated. दिखेगा ही नहीं कुछ भी. Hyper complicated कुछ नामो निशान नहीं दिखेगा. It is such a strong, इतना ज्यादा haphazardness रहेगा. So they find it out that what? These are called azimuthal quantum number. So azimuthal quantum number in a nutshell is what? Nothing but basically is considered to be a suborbit number. And suborbit number represents in the form of what? Suborbit number is usually represented in the form of what? L is equal to n minus 1, where n is what? Orbit number. And once n is orbit number, you can easily go on putting out the values of n, and you can get the values to be as what? L is equal to 0, 1, 2, 3 like that way. And that we prove that n is equal, at its orbit number will be always equal to suborbit number. And the shapes are and represent in the form of alphabetical notification of S, P, D and F and G. Okay. And subsequently written in the form of shapes like this way: spherical, dumbbell, double dumbbell, complicated and hyper complicated. Tomorrow we start with magnetic quantum number.